Hello everyone, welcome to our pre-calculus class. This is our lesson 18, identifying and applying linear functions. And in this lesson, we will try to understand if some function is given or if some data are given, then how we will understand which one is linear, which one is not linear. And then we'll try to see where we will apply that knowledge of linear functions in what type of real life situation. So these are the agenda: identifying linear functions from given function and from given data. Then application. One application is supply and demand related math. That one we will try to do. First of all, how we will understand which one is linear, which one is non-linear. This is the rule. If a function is linear, then average rate of change is constant. There will be like some slope. You will have some slope there. Okay. Average rate of change is constant. And for nonlinear, there will be some exponent, root, x in the denominator, etc. Let me show you that. We have it actually in the next page also. So you see, to be a linear function, see all of them, for all of them, this is the slope. This is the slope. Slope is -1 here. Slope is 1 by 2 here. This is a constant, straight line, constant function. Here also you have some slope, constant slope, etc. So for all of them you have some slope which is constant. A constant number is slope here. And where is the x? The power of x is what? Power of x is 1. Everywhere power of x is 1. Power of x is 1, and here power of x is 0. Power of x is 0, that's why x to the power 0 equal to 1. That's why that is not given. So for the linear function, we can see that is the relationship on their x power, or that is a symptom. Also you can say there is a symptom by which you understand which one is linear. The power of x is 1 or just only 0. For 0, basically it's a number, it's a constant thing. Okay, so all of them are linear. Then see which one is non-linear. The power of x is not 1, this is 2. This is root x. Root x means power of x is 1 by 2. That is the root. Root means x to the power 1 by 2. Then 1 by x. 1 by x means x to the power -1. Then this is x in the exponent. Okay, this x is in the power. So x is in the exponent. Then modulus of x. Modulus of x. X plus 1 divided by x minus 1. This is in the denominator. Okay. So that's why we are saying that nonlinear means in the exponents, roots, x in the denominator. These are the symptom of nonlinear function. And just if you want to understand in one line what does this linear and nonlinear means, that one line answer is all of the function in the linear this side, if you draw their graph, all of them you will have some line, just a straight line, either like this or like this, whatever it is, you will have some straight line. Let's give arrow sign. So some straight line, you will have some straight line if you graph it. Okay, and for nonlinear, if you graph them, it will not be straight line. They will be curved. They will go to different direction. It will not be a straight line for all of them. So this is how we understand which one is linear. All of them are curved. You know, this x is square, root x, or 1 by x. You already know a couple of graphs from here. All of them are curved, or modulus of x going to two different direction. Although this is a straight line, although it's a straight line, but they go to different direction. So for linear, if the function is given, how we'll understand? We'll look at the power of x. Power of x is 1, and then we have some constant number with it, which doesn't matter. Or sometimes power of x can be 0, and power of x is 0 means some number, constant number is there. So this is how we understand which one is linear, which one is non-linear. Now from here, everyone look which one is linear function and which one is non-linear function. Try to identify it, and when you have your answer, then you look at it again. Just pause the video and try to identify which one is linear function here. We have only one linear function here, which is 47 number. All of them are non-linear. All of the other questions that you have here, all of the other functions that you have here, all of them are non-linear. Only 47 number is linear. Now, if the data given, then how you will understand that linear or non-linear. If the data given, then you will understand it from the average rate of change. You will try to find out slope of different points. Then you will see if the slope is same for different points, then it is linear. So for finding slope, you do y2 minus y1 divided by x2 minus x1. So suppose you want to understand from this graph, from this given chart. So what you will do is you will pick any 2 points. Suppose these 2 points, then you put it here. You try to find out some slope. Then you choose the next 2 points, next 2 points, next 2 points. This way you find all of them. Then you will see if it is linear, then answer for all of them answer will be same number. If it is linear, if you find the slope, answer will be same for all of them. And here only for this chart, for this one, slope is same for all of them, for all the things. And let me show you one value how to find out the slope. Suppose you can choose any points. So if we want to find out the slope, we have to choose 2 points. Suppose this point we choose, and then let's say we choose the next point, this 2 point. So y2 minus y1 divided by x2 minus x1. So 47.5 minus 50. This is y2 minus y1 divided by x2 minus x1, that is 30 minus 20. That means 10. Downside is 10 and upside it is minus. So it is minus 2.5 divided by 10. Now you choose any other 2 points. Suppose these 2 points. You can choose any points you like. So for these 2 points, if you try to find out, then it is like 42.5 minus 45. Then divided by 50 minus 40. And then if you subtract it, 50 minus 40 means 10. 42.5 minus 45 means minus 2.5. And you can see this answer and this answer is same. And if you do it for all other points, suppose these 2 points, or even if you take this point and this point, answer will still be minus 2.5 divided by 10 for all the values. Then we will say that this is linear. And if you do the same thing with all this chart and this chart, you will see answer is different. Give a try, and if you can figure it out, check it. Okay, answer will be different. And there is a technique also. Without doing the math, when you become expert, then you can use the technique. You see, This is 20, 30, 40, 50, 60, 70. All the value change is same. See, here also change is same. 50, then 47.5, 45, 42.5. All of them gap is same. Minus 2. This is second value minus first value. That means minus 2.5, minus 2.5. All of them. So if you see that relationship continues without doing the calculation also, you will understand that this is going to be a linear function. So this is a technique also. Without doing the calculation, you can understand it this way also. So there is two ways to understand it. Okay. So, and here if you see 0, 1, 2, 3, 4, 5, 6, 4, 5. So this is nice because change is same, 1, 1 gap. But if you look at this thing 0.09, 0.12, so gap is 9 to 9 to 12. So basically gap is 3. Then this is gap is 4. So see 12 and 16 gap is 4. So basically this is already not non-linear. We can understand it. And for this also you can try to understand this way. The gap has to be same in the both side. If it is not same, then you can do some calculations to find out average rate of change if they match or not. The main technique is average rate of change, because if some values are not given, then you have to take that into account also. You have to consider that also if some values are not given. The main concept is this: average rate of change has to be constant, then it is linear. Suppose if I write 1, 2, 3, suppose if I write 1, 2, 3, and if I write here 5, 10, 15. So this means it is linear, because this side and this side gap is 1 for everywhere, this side gap is 5 for everywhere. So this data is linear. Now see, if I write here 3, all of a sudden if I write here 5, then if I write here 20, then it is not linear, because 1, 2, 3, there is no 4, then 5. Okay, then if I wrote here 5, 10, 5, 10, 15 and 20. So here all the gap is 5, but here this is not same. All of a sudden there is some problem here. So this is not linear now. Now this same data will become linear. This same data will become linear. How? See, if I write here 25. So now see, 1, 2, 3, then 5. 5, 10, 15, then 25. That means for the value of 4, there is 20. That is hidden. It is not given here. It is hidden, but it is here. Do you understand? 1, 2, 3, 4. For 4, it will be 20. For 5, it is 25. So see, the gap is same. The relationship is maintained. The serial is maintained here. One value is not given. It is hidden here. One value is hidden here. So this is what I said. When you just look for the technique, then you have to take this into consideration also. Like, okay, there is like one value hidden. So is it the other relation also fits for that hidden value? Do you understand? For 3 it is 15. For 2 it is 10. So for 5 it will be 25. That's correct. So the relationship is correct. One value is hidden. For 4, this value is hidden. It is not given. For 4 it is 20. Okay, so it is already there, although it is not given. Now it is also linear. My point is this. So 1, 2, 3, suppose this value is not given. 1, 2, 3, 5, 5, 10, 15, 25. This is also linear. Okay, and if you do the formula for average rate of change for finding the slope, you will see the slope is same everywhere for all the points. So for any 2 points, the slope will be same. You can check it. You can check the calculation. In class practice, you will try to do these maths. So why these linear functions are important? why we are discussing it? The reason is we can solve many maths by using this linear function concept. It will come a straight line, then we can actually predict just like this. Okay, just like this, just like the example that I have shown. If you understand that, let me show you that once again. Just like the example that I have shown, I said that 1 2 3 then 5 10 15. Now if you understand, if you already know that this relationship is linear, then actually you can talk about what will be the future of this relationship. For example, if I all of a sudden, if I write here uh, 8, then what will be the answer here? So for 1 it is 5, for 2 it is 10, for 3 it is 15. So all of them basically we are multiplying here by 5. 1 into 5, 2 into 5, 3 into 5. So we know that this relationship is going this way, so we can just multiply it here by 5. 4, 4 will be 20, 5 will be 25, and this way we can continue, but we do not have to, since we already know the relationship. So we can say that for 8 it will be 40. All of a sudden we know the answer. Even for 100, what will be the value? Without going for all these steps, we can all of a sudden we can tell the answer. Okay, for 100 answer will be this or that. If we see the relationship, if we understand that this is linear, then we understand the relationship, then all of a sudden we can say that some bigger value, we can give a big jump, then we can say that what will happen on that date or on that time or on that value. So this is the relationship between, we can predict the future of that relationship. That is the main thing. So Newton's second law of motion, force equal to mass into acceleration, this is actually a linear relationship because this mass is constant. So constant number into acceleration. So this is actually a linear relationship. Circumference of a circle, c equals to 2 pi r. This is r is the radius and c is the circumference. This is a linear relationship. Temperature and cricket related this math. Degree Celsius is, this is the slope, and this is some constant number, this is some constant number, so it is a linear relationship. This is the slope. Average height of human bone, some related to femur, so this is a bone from our leg. Then height equals to this into this, then plus this average height. So basically we can predict, if you know the length of that bone, then you can actually find out the length of that person without measuring the whole body. Okay, so this also helps. And then money related math, salary, we can find out salary, wage, then meals at a wedding reception, how many person coming, what is the per person cost, so we can actually find out the total cost. Then taxi driving, rush hour, what is the wheel, converting Celsius to Fahrenheit. So all of them, just if you see just one variable and then some other numbers associated with it, then we can actually use all of them for our linear issue. All the things that we said in this 2 page, all of them, this all and then this all of them are linear. They are linear function because they have only one variable and the power of the variable is 1. You can see here miles, this is actually one variable. Miles you can write m, then basically, or you can just write x is miles here, then you can put the value, you get the answer. There is no x square, this is my point, there is no c square, so all of them are linear. All of them are related to our real life, and all of the relationships are linear. One application of this linear relationship is supply and demand related maths. So supply and demand means the amount of thing that you want to buy from the market. This is the demand. Suppose you want to your in a family, suppose they need um, 2 kilogram of rice per day, so that is their demand, and if they have that rice on the market, then they have the enough supply like that. Or usually this is goes for some bigger number also. Suppose rice and daily many other things, cooking oil, then vegetables or any other things, all of the things goes with that, clothes and these clothes, and even other luxury items also comes into consideration. So supply means the amount of thing that you have on the market, and then demand means the amount of thing that you want to buy from the market. This is from our perspective, but if you think about a factory perspective, then like supply means the amount of thing that they have, demand means the amount of thing that they needs to produce for the market. So yeah. So supply amount of product, and demand means how many people want to buy it. This is the definition of supply and demand. So one function for supply is SP equal to this and DP equals to this. This function is given here. Mobile phones as a function of price is this, and this is the supply and this is the demand. This is SOP and DOP, some function. This is, don't get scared by looking at SOP means what. Suppose y equal to 60p minus 900. This is x equal to something equal to this into this, like this. And not x. Let's write here m equals to this and n equals to this. Just two different equation here. This is supply function, this is demand function. This is model from real life situation, like how this 60 and 90 comes. It could be like 40 and 300 also, depending on the real life situation. Now if we ask a question like at what price this will be equilibrium. So equilibrium means in the market the supply and demand has to be same, then it is called equilibrium. This is a word. Equilibrium means equal, when it is equal. For example, suppose in a locality total number of mobile phones that all the people want to buy in a month is 6,000, and then if you have a 6,000 mobile phone supply, then it is called the market is in equilibrium. People want to buy 6,000, there is 6,000 mobile phone, new mobile phone coming in that market. So people goes to buy and people have the mobile phone to buy there. Now say 6,000 mobile phone people want to buy, but they go to the market, they don't say, they go to the market and they don't have all the mobile phones there. Like 6,000 mobile phone they want to buy, all the people together all together. Then they go to the market, there is like 2,000 mobile phones. So there is like some sort of need, huge need now there. People will be like crazy. Okay, I want to buy, I want to buy, I want to buy. Okay, and in that case the shopkeeper will increase the price. You know that trick. If many people wants to buy, then there is some shortage, then shopkeeper increases the price of that product. So equilibrium means what? Equilibrium means supply and demand is same. So to find out the equilibrium price, what we can do is we can write this thing. This is the supply equals to this thing here. If we put these two things, then we find out the P. Then that will be the price at which we have the equilibrium. We have the equilibrium. Now you see another way we can control it. This is another way we can control the market. Suppose if you see that people want to buy it a lot, and then you can just increase the price of the product a little bit, then you will see that people now are buying that a less amount, right? Is that correct? If you increase the price of a product in the market, normal regular product, suppose if some mobile phone is normally if a mobile phone is $400, suppose $400 is the regular price, and you see that many people wants to buy it, more people wants to buy it, and then in the next production you just increase the price by $50 or $100, then you will see that now people wants to buy it less. So you just increase the price when you see that too much. uh, Company of course do not do it this way. They take a lot of other things into consideration, then they develop their decision. So um, this is not that straightforward, but just as a concept, this is how they can control the market also. And of course many company actually this is how they control the market. And also if they see that there is like less demand, then they decrease the price, they give the discount in many ways. And they say okay, $300 now, who wants to buy? And people will think okay, the price was $400, now it is $300, so I have $100 profit here, so I will buy this mobile phone now. So if the price goes down, then this way it works also. So this is how people controls the market, those who are these big companies. So they need to find out what is the equilibrium price first of all, so that they can increase or decrease from there. Equilibrium price means the price for which supply and demand is same. Now if they increase, suppose equilibrium price for some product is, let's say, $500, suppose, then if they increase the price, that means people will buy it less. If they decrease the price, then that means there will be some loss for the company. That means some loss for the company. But if they want to embrace that, then that's they can do that. But if they decrease the price, people will buy it more, that's for sure. So this way it goes. Anyway, now if our question is find out the equilibrium price, what do the companies want to find? Why do the companies because to make as much money as possible, to make uh, profit. Why this equilibrium price is needed? To make profit, because that equilibrium price is the price where your supply and demand intersect with each other, match with each other. Match with each other. Suppose if if a product is worth $200, that means if you know that this product, even if it is $200, then still people will buy it. If you know it from the equilibrium price. Now suppose you do not know it, you are selling your product at $150. That means basically you are actually selling it in loss in a sense. You could make profit $50 more from the market. And say you are selling your product by $250, which is extra money, more than the equilibrium. Then people will buy it less, and you will be like, I do not know what is happening. Oh my god, why people are buying it less? Actually your product is overpriced, that's why people are buying it less. Your product worth $200, that's why it has to be, the selling price has to be near or just exactly at $200 to make your maximum profit. If you increase the price than this, then people will not buy it. If you decrease the price than this, then basically you are in loss, because your production cost is near this $200. That equilibrium price actually finds all of them. So if you want to find out equilibrium price from this product, from these two functions, then what you do is you write supply function equals to demand function. Then you actually find out this is equilibrium quantity, is 2100 phones, and price is $50 for this math. How do you do that? How do we do that? We just, as I said, we just write this function equal to this function, this whole thing here. Then you do some calculation, you will find out P equal to what? That P is $50 coming. Then if you put the value of 50 in any of this equation, then you will find answer is 2100. That means for this situation, $50 is the price of the mobile for this situation, and if they give $50 price, then they will sell 2100 mobile phone. And where the supply is greater than demand, if that is the question, then you see we can actually uh, consider it S of P supply is greater than demand. So S of P is greater than D of P. From here, then you put the value of S of P and D of P, you will find price is greater than $50. If the price is greater than $50, then supply is greater than demand. That means if the price is more than $50, $50 is our equilibrium. And now if you start selling, the quantity is selling your mobile phone more than 50, that means people will not buy it. That means supply is now more. In the market you will see there are a lot of mobile phone, but people are not buying it. Why people are not buying it? Because the price is more than 50. That mobile phone worth $50. Price is more than 50. That's why people are not buying it. Okay, so that's why supply is greater than demand here. And how do you do it? You just do it from here. You write sp greater than dp, then put the value of sp and dp, then do some just 2-3 line calculation. You will get it just like this one. P equal to 50, but here it will be greater than p is greater than 50, because of this greater than sign. Graph sp and dp, and the equilibrium, to find out the equilibrium point. So sp and dp, if you try to find out, if you draw it, then you will see that the function actually will intersect at a point, and that point is the equilibrium point. This is the sp graph, this is the dp graph. How do you graph it? You put some value of p here, then you plot it, and then we can actually find out. So this is graphical method to find out the equilibrium point and equilibrium price and equilibrium quantity. This 50 is the equilibrium price, and 2100 is the equilibrium quantity. This is the graphical method. This is a number. By the graph also you can solve this a number question. You do not have to do any calculation like this. You just have to graph these two functions, then you will have it here. So this is another math, supply and demand related maths. Same type of question, like equilibrium price, demand, where demand is greater, then where is the equilibrium price and quantity. So this is the same type of math. This is another math. For this math, SP, two functions are given. So what will be the equilibrium price, what will be the how do you graph it. You can practice these maths and see if the answers are agreeing with you. And these are the homeworks related to this 40 number, 39 number. These are somewhat related to supply and demand related maths. And 25, 26, they are related to linear and nonlinear function. And 45 is related to depreciation related maths, which is the concept is somewhat related to the supply and demand. Kind of all of them are linear. This way they are related, but this is actually decreasing kind of math. Give a try, and if you still face problem, then we can discuss. So that's all for today. Thank you all. Thank you very much, and have a wonderful day and wonderful break. Actually, the break is coming up, I think. Bye bye.